767?
Oh, okay.
No, 676, sorry.
But where do we move our website?
All right, if you want to attempt this, like I mentioned the other day, I'll give you 3 extra credit points if you get it right. I'll give you 1 just for attempting it and turn in whatever you get. If you get it right, I'll tack on. A couple things about the object first off is this dimension right here for the height of this guy is given, kind of hard to see, there's like a little 75 right in here. Is that right?
We got that, I can't see it at all.
We got a glare going right from that window over there.
Okay.
Anyway, this is 0.75 high. Now, the thing you gotta kind of figure out with this guy is where you're gonna pick your front view. Because you can choose a lot of different things. The thing is, if you pick like this or this, where I'm coming in perpendicular, I'm looking perpendicular to these faces, then orthographic projection is going to do a great job on this base. It's going to totally describe the whole thing. But then the top piece is all oblique, because you don't get anything. In fact, well, it's inclined and oblique. If you decide, well, I'm going to look at it like here because I want this true size and shape, and I choose that for my view, orthographic projection again would do a great job now describing the top. The bottom's now all oblique. So you got to make a choice. I chose this for my front just because I figure, hey, this is a base, it's a stand, looks like it slides over some device to hold it. This is probably the bottom, how it runs in production. That's the only reason I chose that. You can choose a variety. So I chose here. Now, the thing is, that does a great job, like I said, on the base. The problem is, this is all oblique. How do we tie the two together so that I can draw this in its same space? Now, the trick to it is really understanding what's true length and what isn't. Remember, when you get those obliques or inclines, then we got to look for edges and we're looking for true length lines. Okay. Well, let me go to the projection. Okay, so here's my front, top, and right side view. Now, the base here is all done. Okay, I've described everything. Now I'm getting ready to tie the top, and the thing to remember is that base, it sits and comes back here, but then it's also tilted up, right? But they do give you this line. That line's sitting right here. Now I've got a fold line in between these two views. Is this line parallel to that fold line? Yes, it is. Therefore, it's true length. That line is also common to the plane of the object. So there's your rotation angle right there, because that's law 1 on that front face. Then I can apply law 2, I can apply law 3. Now, what you want to do is set up your fold lines. So let me show you my fold lines here. Okay. So here's the one that's in between here. Now, I then went and set this one right here perpendicular to my true length line. Okay, perpendicular. Now, I need to go back to the view here real quick in the book. Now, the orientation I look at, what I'm looking now here, I want you to focus on the top view. So I'm looking straight down. And I know this is my true length line right here. Okay, that's the one. And that's the only line you can really find. You can't find this back until you draw this. Okay. Now this true length line, if I'm looking straight down, what I really see also is I see this as an edge. Right there on that edge when I do my top view. Because it's been rotated back that 30 degrees, you'll see that as an edge. Therefore, this is an inclined plane. This one's oblique. This one's oblique. The back side of it is inclined also. So I got 2 choices. Both of them give me the same rotation. Since I'm already on an incline, looking from the top view, I can go parallel to that surface, or if I'm dealing with this one, I need to get point view for edge. Either one, they're all tied together at that point. And let me just show you how that works. Okay. Once you kind of recognize that this is true length and I'm going to get an edge view on this on my top view, then it kind of starts to fall together. Okay. So I'll go back to the computer. Because when you draw this, let me just kind of move a line here. Here's my center point. Okay, there's the edges of that plate. But it's rotated that 30 degrees right here. Now, I see those as edges. Now, this is all foreshortened because it's tilted back 45 degrees too, right? So we just got to recognize that's foreshortened, there's the true length, therefore this is edge, this is an inclined plane. So I'm either doing law 1 on this plane, or I'm doing law 2 for the front plane. Both of them give me this fold line in this location. Because law 1 states, plane will appear true size and shape in view and plane parallel to it. So if I'm dealing with that edge, it's parallel, I'm going to see this side right here, true length right here, true size. I will also see point view of this line right here. Okay. Now, once you do that, then you have to locate it. And once you get this first one located, because this 45-degree angle is kind of tricky. Okay. Now, keep in mind that I project perpendicular to my fold line. Now, I know that this point right, this line, will appear as a point somewhere over here, just I don't know where. Okay, it's going to fall the distance from fold line to point right here, because I always need 2 views to build it. So I'm going to come in here and do an offset from here to there, and offset this one out. So what I just did is I measured distance from fold line to where that point resides. I'm sitting here. And then I'm going to rotate it, and it's going to come back and be right there. So I'm going to see this as a point. Now, the other thing you got to do is get that 45-degree rotation in there. Okay, and that's, it kind of helps if you got visual aids on this. Because if it was true size, it'd be there. We'll rotate it back 45. And then I'm going to rotate to this view. So the thing's going to be sitting like this. So this front edge right here is going to be coming back 45 degrees. Can you see that? If it was straight up and down, it would come straight back? Okay. Well, if it's rotated and I come, it's now in that orientation right there. Okay. So once I find that first point and I get the rotation angle, it's going to go from here to here, and then let me rotate that 45 degrees. It's going to go on that orientation right there. That's going to be that front edge, which is this one. Now, let me just move this in to kind of speed it up. So that's this view. Okay. Now, once you have that view, you can draw this because it's true size and shape. And you've got this line. Okay. You know the height of it, you know where everything's at, it's all given to you right in the text. So you'll draw this true size and shape. Now, once you do this, notice I now have edge view of the front plane. I've got edge view of the top. To build this view back up, in essence all this stuff, I need to have 2 views, so I've got to either project to the top or to the front. And I did both because I used both of them in different situations. So I've got edge view, there's my fold line, this is true size and shape. Now again, you need to maintain distances. So when you set that up, keep in mind you project perpendicular, and then the distance from fold line to point will be fold line to point. I'll show you that just in a second. So that's how I set that one up. And then to do this side, I threw my fold line clear out over here just to get it away from my view. But again, this line and this line are parallel. Okay, that's law 3. So I'm going to see true size and shape. Now the distance from, again, I need 2 views. I project from this one. This one is fold line to point, fold line to point. And once you get this, I would recommend, once you do that, go to a reference plane on everything you do when you do reverse construction. Because you got to build this view, maybe even build that view. But you have to use reverse construction to get these ellipses. Here's where I see the circle. So to use a reference plane, it's right there. It's sitting right on this front face. Here it is again, here. And so when I bring the measurements, I don't have to go fold line to point, fold line to point. I can just use reference lines. Okay, it kind of speeds you up quite a bit.
And can I have a question? So the circles are, so you're doing the diameter for the first one, which is like 0.5, and you're doing the diameter of the circle behind. So it's cutting down. So you're doing 2 diameters, you're not doing.
Yeah, because
Yeah,
it's,
you're
you
doing
got
0.5
to.
and 0.2.
You see them both true
Yeah,
size right here.
Exactly, I hadn't, okay.
You see them both true size right there.
So you got that one and that one, so the point of the two, where that's 76 degrees, that's the diameter, okay.
Yeah. Okay. Should I show you how I build one of these? Or what do you, that's your setup. Once you get that, you just do a reverse construction back through it. And you end up with something, there's your 3 views. Okay. This is not how I really print it. I got another one. I basically take these and create a 3-view on it also. But the thing is, you can kind of see as you get into here on my top view, there's that lower track. I see parts of it here, and then it goes away. Let me just real quickly set this up from my original here, so to show you how I do that. We're going to these perpendicular snap. Turn that on. Okay, I got it. Okay. So here's where I'm sitting. Set my fold line, there it is. Now I'm going to come perpendicular to this guy. So I'm just going to pick a spot, and perpendicular. Come on, give me an effort. Let me move that to here. Now I need to draw my fold line. So what I'm going to do is just draw a line that is going to go perpendicular. And this is my fold line. You can put it wherever you want. Now, once you have the fold line for the view you're creating, then you need to make sure that you're using this one to do it. I'm going to slide this out of the way for a second. So there's my fold line. Now, let's go ahead and do this first one right here. So I know it falls on this line, and it falls in the distance from here to here. So there's that front edge right there. And I'm just going to rotate this thing. And I'll rotate it 45 degrees. There's my front edge. Now at that point, I'm just drawing. Perpendicular. Perpendicular. Move. There. And I think this base is rotated at the same 45. Like such.
Oh, so you come from back here. Okay. And that's
Okay, how high is this thing? Like 3.6? Okay, so there it is. And we'll do an offset, and the thickness is 0.56. We kind of trim this up a little bit and give it. How far down is that trench? 0.25. I think that is 2.4 down to the center, right? Now, we also got a circle on it, but I'm gonna add that at the end. Now we got this bottom part filled in. That's got a radius of 1. Trim, no trim. Radius of 1.
That's all you need for this one.
Okay, so there's the object.
Okay.
So once you have that one,
Thank you.
make sure you're saving these fold lines because you're going to be using them. Now at this point, let's go ahead and set up the top. So let's do an offset of like 4 units. And let's change that to a fold line. Now I know this line is coming from here, perpendicular, right? And let me just throw a line up here and extend to it. Okay. So I know this thing sits on those 3 lines, right? And in fact, there's another one down here for the fillet. What I don't know is where they fall. Well, they're gonna fall fold line to point will be fold line to point. So I'm gonna come in here and offset from here to, can't remember if I force that to perpendicular. Okay, so there's that one. Okay, there's the front edge. Now let's do the back edge. So that's right here. So I'm doing an offset, fold line to point, fold line to point. Okay, there's my 2 edges. And so this guy's gonna sit. Just like this. These are going. Okay, so there's basically it. Now at this point, when I build this, you can use a reference line on this guy too, because you're now true size and shape. So that's got a 60-degree cut, right? I'm looking at that. So I'm going to get some snap lines here, going edge to mid, my offset. And 24.
That is 24 from the
Yeah, that's the bottom trench, right? And then it goes up at 60 degrees from there. And the 60 is what? It's the interior angle, right? Okay, so I need to rotate this line minus 30. That should leave me 60 right there. Do the same on this one. That's 30. Okay, so there's my top view. Then you do the same thing to set up your front view. Now to set up your front view, let me just kind of do it so you see it. Kind of throw it over here somewhere out of the way. I like my fold lines to be big enough that I don't ever not get down. So there's my fold line that's parallel to this front edge. So it doesn't matter where you put it, what matters is from fold line out. Okay? And I have to set it up with this view. So the distance from this front edge to this fold line will be the same as this front edge to that fold line. So first let me project from this view, I'm going to go perpendicular. And again, I got to go past it a ways. So there it is. And let me just, I'm just going to copy that guy to the top. Come on. It's the computer's fault, not mine. Okay. there's my top and bottom. Now, where does it actually occur? The distance fold line to point. So I'll do an offset, fold line to point, fold line to point. And then get the back side of it, which is right here, fold line to point, fold line to point. Okay. So this is where the object sits. And then I can go ahead and now draw that front piece on here because this is true size and shape. Okay, so you can then draw, you're drawing all of this stuff right on there. So that's kind of the setup. And if you choose different, like Gabe, I think you chose yours in a little bit different where you went, this is your front, is that correct?
It was, and then I tried to do it, and I was using all
Okay. But regardless, yeah, I think this one keeps the front close to you a lot. Once you get these views set up here in the correct orientation, then you can come back and say, okay, well, I'm going to build this top view right here. Well, I use this view and this to build the top. I use this and this to build the front. Once I have this view done, then I use this view and this view to build this view. Because you always have to have two views. Once I have these two done, then a standard orthographic projection to build this one. Okay? Where I'm using a meter line to come over and out. And I think I did take time to save all my construction lines on here, which are there if you really want to see all the projection lines. There's a lot of drawing to get this thing correct. Let me actually, I think I segregated it to top. I want to see X here. Okay, so X1, that was setting everything up. And X2, okay, this is, you can kind of see the production lines here. Now, the ellipse has changed since I first drew this. I graded this out as a irregular curve. Now you can just take your center and your two axes for the ellipse. So you don't have to project all these lines like I did back in the day. And once you're done with that one, then you're building this guy right here. And once you've got that, then we're coming to this guy. Okay. So these are just projected straight down and across. And you can build it. Okay, so that's the setup. If you get on that, I think you're a long ways to having a successful completion. Tomorrow, because we're coming up on lunch, that's get you set up. Does anybody have any questions on how to set the object up with itself? Okay. Once you get that, tomorrow I'll run through with all these set up and show you how I build this view and then use these two to build this view. Okay. So for now, try and get it set up if you want to take this. Like I said, I'll give you 1 extra credit for just trying it. I'll give you 3 if you get it right.